Hello, this is the Blast Report podcast on all things blasting. My name is Evan Tebow with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. And we end the last podcast and we go into, another episode here is, that Tristan and how where that plays into, and you had mentioned that's something we didn't talk about on the first episode, and so just go into there and how you guys not only work together, foster each other's careers, grow an entire program, but it's also entirely in the family as well, right?
Oh yeah, and Tristan, just to let you guys know, most of the guys know my son Tristan. Okay, he's the third Worsey, right? Tristan Worsey. And, I'm real proud of the guy, but, man, he was always trying to outdo me as a kid, right? And he'd do something, I've got a reputation for being pretty crazy, Evan, right?
That is true.
And I've got this sense of humor that is just sometimes you have a opportunity, right? That's just too good to waste, right? And so he's always trying to outdo me. And at one point I said, "Nah, okay, Tristan, you beat me," because I could see where this was going to go if we let it go any further. I had to succumb to him, right? Because it was just getting a little bit too far gone. But Tristan, okay. He was out, I think it was with Braden Lusk, okay, who's president at the moment of Dino Americas.
And executive.
Yeah, he's also the ISCE president.
Mm-hmm.
And a great guy. He used to be, I actually taught him as a student.
He was one of my professors, and it was, everyone always kind of said protege. He's your protege, right?
So, this guy is one of the, I think, the best student I've ever had. And, he's just a fantastic guy, real fun. And we clicked so well that I had him as my TA in the blasting class before he graduated. And then he said he was always going to come back and everything. And I go, no, he's going to be off in industry. And, I'm going to do a PhD. And one day I got the phone call. "Hey, it's Braden. I'm going to come back and do a PhD." "Okay." Go, "When are you coming?" He goes, "2 weeks." So I went, okay, right. So I had him as a graduate student as well, and worked really well as a team together, which is
probably going to need to have him on this podcast.
So anyway, so he's seen.
He will never have the time.
No, that's true.
Time, yeah.
That's
so,
true.
Because he's a busy dude. He saw Tristan come up, and it was always the big joke about Tristan and me, right?
Mm-hmm.
And father and son, and how we were so similar but dissimilar, right? And it was always this competition going on. So he was off with Carl Perry, who was also one of my students, right? And they're with Tristan, and I can't remember where it was now, but I heard all the story about it. So they're walking down the street or doing things, and Braden go, "Oh." And now, my nickname, is P-Dub, right? P words.
Yeah, P-Dub, yeah.
And Jill's nickname is G-Dub, right? So the two of them walking down the street with Tristan. Tristan would say something, and then Braden would say, "Oh, that's P-Dub," right?
Yeah.
And then he'd say something else, and then Kyle would say, "That's G-Dub."
What does he say that ends up being more mom? Yeah, is that more like my mom, more like my dad?
Yeah, so they were picking up all these things. So hopefully he's got the best characteristics of the two.
the mix of you.
He's doing great, so it's pretty.
And that's now him being T-Dub.
Yeah, he's T-Dub.
And there's definitely some T-Dub things there too, you know?
Yeah.
Wow, okay. And so, you know, growing up as a kid, that's something that I've always noticed now here, and I guess I could talk about, and I'll interview him on what it was like growing up at these, you know, and growing up and being a part of this is probably an interesting thing. And there's so many people in this industry who are multi-generation blasters or mining guys, and I had no idea that that's the case, right? There's my father's is a ski instructor and it was chef, you know, back in the day, and my mom's an RN, so I had no clue what was going on, right? And I come in here and they're like, oh, that's Paul Worsey's son. And I remember I don't know, I probably shouldn't tell this story without him being here, but it was one of the funniest things. And he was gone. He was in Australia and he come back. And so I just finally really got a chance to meet him. And there was someone from HR of a very large company who came in and gave a presentation on how to hire and what students should be doing and shouldn't be doing to get jobs with this very large company. And Tristan's just comes back from Australia, old tan, long hair, you know, and it's like, hey, that's Paul's son, you know, and people will talk about him. I don't know him yet, but he's in the back of the room. And this lady goes on and on this whole time about how you can't have photos on social media of drinking or doing anything. You can't. You have to be so well behaved on your social medias and everything. And she hardly even talked about the company. Hardly even talked about explosives and mining. Just started ranting on, you know, how your Facebook, it was at the time, how your Facebook shouldn't have this, you know, it's a bad image and all these things. And then, so she goes, does anyone have any questions? And your son raises his hand and he goes, at what point do you look at our resumes? And she, oh man, it was so funny. Everyone laughed, and then he described, he's like, well, I mean, in all reality, if I can maintain that work level and have whatever kind of fun I have in my social life, and then and still be high performing in my career life, you're looking at the wrong resume of somebody. You know, this is with my friends and who I am in the background. But if I can entirely be as successful in the work aspect, and you know, so he not only did he say it in the nice sarcastic P-dub way, but he followed it up with the G-dub way. You know? It was pretty awesome. Like I thought that was pretty funny. Yeah. And when it comes, and now like Tristan, you know, your son he's off and he's doing his own thing, and you know, he's moving to Australia and things like that. And now have you, like, when it comes down to being the mom and dad, and then also in the industry, you know, he learned at some of your big bonfires, to big bonfire and firework days, right? So he learned how to tie in a squib at at home, like with, you know, as part of the family. You think that like what's some maybe story there, or talk about you know, what was it like also? Did you try to push him into explosives?
No.
Or no? That's what I'm saying. That's what I'm. No, not at all, right?
Yeah. Do you want to cover that one, Jill, with him when you asked him what he wanted to do?
I don't remember that.
You do. You asked him what he wanted to do, and he's like, well, he goes, Dad travels all over the world. And I don't like the idea of travel, so I think I'll do what Dad does. So, I think when you went back, we were talking about, you know, there's a lot of families in this business, right, where you've got father, son, and stuff like that are in the same profession. I think maybe
mother-daughter with the guys at HTA, right?
Yeah, maybe it's not maybe it's not that people are following the parents, but okay, they're, you know, exposed to it. Where, as you said when you started off, man, there's a place you can blow thick shit up, right? You know, there's a degree, and that was an eye-opener to you, right? So if you don't know about that, and a lot of people coming out of high school, you know, the only thing they've ever seen is chemistry, right? And they all want to become chemical engineers, right? And chemical engineering is basically the antithesis of explosives.
I was told it's chemical plumbing.
Yeah, but chemical engineers are there to make sure things don't blow up. Right? If things blow up, it's a very, very bad day. But
same with rocket scientists, right? They're almost the same as us, but if they screw it up, it detonates, and if we screw it up, it deflagrates, right?
Yeah, that's right. And people say to us, well, you know, what would you do if you had an explosion? I've been asked this at the university, and we go, by the safety people, we go, yay! We'll start hollering and having a good time. And they look shocked at us, and that's because, and I say, if it doesn't go boom, people start crying and, you know, very, very disappointed.
Yeah.
So,
and you're talking about getting people to understand that this is an option and a career and make that decision. It's funny you bring that up. Actually, tomorrow I'm going back to my high school for career fair, and gonna talk about you know, the industry. And it's funny because, you know, I only knew about it because that one newspaper article of you with a tamping rod, you know, tamping down like a 3-inch shell for a fireworks show on the university. No, it wasn't. It was a small shell, but and I got to see that. And so I said, you know, there was a career fair that I went to at my high school, and they said, oh, what, you know, we went around the room, and you said, what do you want to do when you grow up? And I said, I want to blow stuff up. Obviously, everyone laughs, right? And they're like, oh, ha, 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 you know. But I don't even know who the guy was, but the guy said, then do it, you know. And I was like, huh? You know, everyone kind of stopped laughing. He was like, do it. Like, you can do it. Like, that's the career. If that's, you know, like, it's not, you don't have to pigeonhole your a kid's career into doing what you want them to do, but they'll start to see that passion and want to follow in that direction if they can, you know, do what they want to do.
And that's very important. And, you know, to kids out there, if anybody's listening to, or somebody that's in a position they want to change the job, having a job that you really enjoy, it's worth taking a slight pay cut for.
That's a fact.
Because it's great, and you have a fantastic time, right? And that's super. But here's my advice I always give to the students, right? And maybe this is not politically correct, but if you work for an asshole, right, what you need to do is go out there and find the best paying asshole you can and go work for them. Because an asshole's an asshole, but you get financial compensation for working for an asshole. And it's as simple as that. And then, if you like going skiing at the weekend, you can go and fly somewhere and go skiing for the weekend, right? It's as simple as that. But, you know, you're getting paid for what you do. And if it's not a great job, you need to be compensated better for it. And that's what it all boils down to. I got offered a gig in the Gobi Desert. And it was like, that's interesting. And it was supposed to be, I think I was going to be the production manager of sinking the shaft to what would be the world's largest gold mine. And there's not too many people that sink shafts, you know. And so if that was on my resume, that would be pretty premier thing to have on your resume. And so I was like, I'll consider moving to the Gobi Desert. You know, I was like,
doing a lot of research on what it's like to live in Mongolia,
Yeah.
you know, and what kind of cheese do they have there? Like weird things, you know, and then I find out it's one of like the poorest countries in the world, but because it doesn't have a food shortage, no one knows about it. You know, it's like the second poorest. But the reason I brought it up was because they were like, yeah, here's the job offer. And it was like 3 months on, 20 days off, you know? And I was like, oh, excuse me? And then they said, yeah, 3 months on, like 20 days off. You have like a weekend off every other week, but you're staying at the camp. No, you have weekends, but you're staying at the camp in the Gobi Desert. And then I was like, and how much are you paying me to spend the early part of my 20s?
Yeah, but you're getting the privilege to work to live in a yurt.
Yes.
And then
no, it would have been a sea can. It would have been a glorified sea can, but the pay wasn't even
I don't know.
there.
I've had some of my past students have been out there on greenfield operations. They've lived in yurts. And
I would do that.
Then you get to play polo with the locals with animal parts, right?
That's, yeah, and have a pet falcon. No, but they were not willing to pay me. Like, there was hardly even a pay increase, and I'm like, guys, I live very comfortable in America. Yeah. I'm very privileged, you know, in what in pretty much any job in the explosives industry. It's long hours and a lot of work, and probably high stress, but I think it pays well.
Yeah.
And there's also emotional reward with pressing the button as well, right? I met a guy last night. He said there's a joy of pressing the button for a living, but the joy that you really get when you see someone press the button for the first time and you see the smile on their face,
that's even more.
That's even more, you know.
And most of the time I never get to press the button, but whenever I go to board, I go Brazil. I was in an underground coal mine, and they said, hey, you want to help load this shop? Because I just give a short course. I said, yeah, and they're all really excited because they'd never seen a professor load a hole before. Like, I'm loading holes real quick, and they're going, oh, you know, yeah, you want to shoot it? I go, hell yeah. So, and I get the pleasure of, when I go out on these shoots, they'll let me shoot. And usually before, when I was at the university, unless I'm doing some research, it's always students in class get to shoot stuff.
Students get to shoot, and I've heard so many stories of, bringing your family to work day, or if you've got a customer that's not happy. That's what we talked about. One of our guests on the podcast, Mike Kaler, he says, he was talking about a big project where he let someone press a button, but it's interesting. A friend of mine said that when we grew up, we would go to the shooting range, and it was my friend's father. And I just saw him for the first time in quite a few years. And he's like, are you still doing that explosives thing? You still blowing stuff up, And they never seem to understand civil explosives and stuff. They just say blowing stuff up. And I'm like, yeah, I'm doing that. And he goes, then we talked about how we used to go shooting at the shooting range. And whatever we would go shooting at, I didn't really care if we were hitting it at the time, because it was just it was the joy of that. And he says, you really did like pulling the trigger. Right, and so it's so cool to see that, and I know we kind of got off topic here on this episode, but it's there's just so much to be said about getting people into this business and the joy that's involved, and whether or not you come from a family that does blasting, or you just got into it, right? And that's really cool that Tristan made the decision on his own to do that, and you guys gave him that opportunity to say, hey, what do you guys want to do?
And it's great. So, you know, this has been a fantastic conference for me here, this 49th International Society of Explosive Engineers Blasting Conference. Out of the papers, was it 19 of the papers had authors or co-authors, which were my students or students of the program. Okay, the guy got the best paper award. He was actually on explosives camp, one of the kids that was on explosives.
Really?
Yeah.
Who was that?
Mark Herman.
Mark
Would have been
Herman.
after you. That's,
Yeah. And,
Wow.
okay, Braden Lusk, okay, he's the president. And then Tristan in this issue of the Journal of Explosive Engineering, right? The Science Journal. He's got a paper in there, one of the two papers that are in this issue of the journal. It's handed out at the conference. So, you know, it's been great. And all my old students bumping into all the people I know over the years. It's been fantastic. And I just feel so great. And I can't tell people enough how great that feeling is to be a part of something that's grown and you're proud of how it's turned out. You know, when I first started off, Hercules had these pamphlets on how to blast. And some of the stuff in there is 180 degrees different to the way we teach it these days. And so the whole industry's come on fantastically. And
like the rule of thumb, like there was too many, like these old school rule of thumbs. Is that what you're saying?
yeah, well, no, but they're still used. It's a good starting place.
Okay, but okay, I see what you're
Yeah,
saying.
but people have got to understand this. Not everybody wants the same thing out of blasting, right?
Mm-hmm.
Some people want big rock, some people want small rock. There's no way you can use one equation for all of that.
Mm-hmm.
It's as simple as that. You've
Very
got a
true.
starting place, and that's a good starting place, but you need then know this is what works, and this is what I'm going to do to tailor it to my requirements. And then you've always got a little bit of experimentation there to get exactly where you want. But
And so they had this pamphlet on how to do something, and now you guys have a family, and then also you got Nathan Rouse, Tristan's neighbor next door, or pretty much best friend. He gets into it, comes and gets a PhD, right?
Yeah.
He was the first master's student.
He was the first
Graduate.
master's student.
Yeah, he was the first master's graduate.
Going back to the old Hercules thing, they had joints, and they had joints at angles. They weren't 90 degrees. And then what they said on that pamphlet is you drilled across the X, okay, and you blasted so it came out on the big chunk side. And that was the most efficient way to blast. And that's completely wrong. Because what we want to do if you want a great shot, is shoot so the back are either parallel to or perpendicular to the main joint set, and then you get beautifully clean faces, and then you don't got this raggedy ass shit face that God knows what the burden is when you put your hole, and then you're going, oh, I'm gonna have to move this hole on the front row, and it just becomes a mess. But I don't know if you saw it on some of those shots on the video roundup.
Oh my gosh!
Yeah, they had
what a level that they've escalated to.
Yeah, they had one where they shot a triangular shot instead of a square shot.
Yeah, I saw it.
And you know the reason why? They were swinging their face around the best blasting direction, which is either parallel to the main joint set or perpendicular, so you're cutting straight across it. And that way you don't get a zigzaggy face, you get a nice smooth face, your first row set up.
That was an aerial shot directly above in a nice slow motion to see each row went off. Yeah, that you could tell everyone. That was a long video, but it only needed one shot in that video, and that was it.
Yeah, but
that could have been a 20-second video, but that was nice.
What people probably missed was it was a triangular shot.
Right. It was
And
a pyramid.
They were swinging it round to the best direction for shooting.
You could, yeah.
Actually,
you could really see that. Wow.
Yeah. Well, we understand now because when you mine somewhere, the only time you need to blast aligned to your property boundaries is when you get there.
Yeah.
Right?
Yeah.
So if you've got a shot where a mine where you've got a bad direction and a good direction, okay, or multiple bad directions and multiple good directions, it makes sense to blast in the good direction, and then finally, when you get to the property boundary, then swing it around. Okay,
so when if you take that, and I know there's a lot of issues with pre-split, and you were mentioning earlier that was a lot to do with what your very first thesis was, right? Was pre-split blasting and stuff like that. Do you want to go into that? Like, do you want to talk about your very first project and how you guys worked on, like, it was pre-split, and that's a line, right? You have to shoot to the property line, and you have to establish your high wall. Do you want to talk about what you guys found out then, and is it still relevant, that many years later in the industry?
Yeah, so what it boils down to, there's AutoCAD and then there's real life, right?
Mm-hmm.
So somebody draws something in AutoCAD, it looks always perfect. I mean, your holes are exactly the right place, they're exactly the right angle. It's a technical drawing, but then there's reality, and you get out in the field, and can you do it exactly the same as in the drawing? Or how about your crew? Okay, are they trained up and knowledgeable enough to understand how to do it like it's in the drawing?
Mm-hmm.
And then on top of that is understanding geology, and that's a big thing. So you got to understand the rock you're blasting. If you don't understand the rock you're blasting, okay, Mother Nature will bite you. It's as simple as that. Always remember with Jill, every year I go, oh, okay, I'll get some chocolates for a birthday, right? And she's just dying laughing here at the moment. And this is peed up, right? So I go, oh, I'll get her some dark chocolates. I like dark chocolates as well. And I go, what are you doing giving me dark chocolates? Right? I don't like dark chocolates. I like milk chocolates. And this would happen every year, right? Because, hey, I'm peed up, right? My mind's somewhere else. And then this one year I gave her dark chocolates, and I said, what? And she goes on at me about these dark chocolates. And I go, well, who is it that likes dark chocolates? And they go, oh, it's my mother. And that was I didn't get steak dinner that night, let's just say that.
But since then, you stopped buying dark chocolates?
That's right.
Yeah.
So,
it was someone else very important in my life. This is the wrong one.
When you're working with Mother Nature, you have to cajole with Mother Nature. There's certain things that Mother Nature doesn't want to do. And geology's that big one there. So we're up in the Highlands of Scotland. At that time, there was $20 million pounds, and this was in the late 70s, of claims, excess claims on rock excavation per turn that were directly linked to blasting.
Wow.
And back then,
how many million?
To a pound back then.
Okay.
So that was $80 million.
Back then.
And that was in the 70s, so geez, I don't know how many times we're going to multiply that, but I'm saying it's well over $250 million or $1/3 billion in today's money, right? Because you've got to, bump it up there. So that was a big deal, and I had to find out what they were doing out there in the Highlands of Scotland on this big contract that was going through the mountains, A9 realignment from Calvine to Aviemore, and right through the worst of the mountains. Very, very dangerous road. They were putting in dual carriageway road, but they had to have two roads at slight separation because of the mountains, right? And it was one of the first big mountain projects that they had in the UK, well, in Scotland. And it was quite something, and the geology did have a big play. The other thing that was the problem is the guys who were doing it didn't know what pre-split blasting was. And a lot of times they were shooting it after the main blast, so it was just smooth rolling instead of on the first delay of the blast, right? Or shooting it beforehand and then drilling and blasting the main blast. And the main blasts were using vertical holes, and the pre-splits were all at angle. And a lot of the guys have got no idea of 3D view of it. So you'd walk on the surface and they'd be drilling vertical holes all the way up to the pre-split line to within maybe about 4 foot of the pre-split plane. And the pre-split plane was dipping at about 70 degrees. So all these main blast holes were being drilled straight through the pre-split plane. And the only plane, yeah. It's so, you know, you're not going to see a pre-split, right? And other places, the rock was, there was bad directions, so it ended up breaking to the natural joints, the viscosity, and made very zigzag cuts. Other places, if you'd cut that rock with a diamond saw, it wouldn't have stood up, it'd have fallen. And people just didn't realize that
didn't matter what was happening.
When you blast using explosives, it breaks things, right? It doesn't glue things together. You can't use explosives to glue things together, right? And they just didn't quite understand that one. So there was very, very poor. I went on that project and I thought, oh, this is, man, there's a lot of engineering here. They got 78-degree slope and they got like a 72, I can't remember. Some of them had half degrees in them. And I thought, man, these people have been doing this rock mechanics work on it. And, you know, I was just a PhD student at the time. And I'm thinking, wow, you know, someone's been doing some real engineering on this. And then the more cuts I saw, the same numbers kept on popping up. And I'm like, hang on a minute. I'm seeing the same numbers. So I started plugging them into my calculator, right? The basic scientific calculator back then. And they would just start to come out, you know, where they were cheap enough to buy. And I was plugging in the tangents. And all of a sudden, it was a slope ratio. It was like 1 in 2, 1 in 3, 1 in 4, 1 in 5. And I'm going, oh crap, the people who are designing this are quantity surveyors. They're balancing cut and fill. There's no rock mechanics or anything taken into consideration of geology. It was a bunch of quantity surveyors that were doing all the design work.
So they were just simply letting they were looking at survey work instead of saying where is the joint and spacing and the strike and dip of this actual rock.
Yeah, there was
maybe it needs to be turned a little bit, or maybe that amount of rock needs to be pulled to a certain distance.
Yeah, so all the slope design was based on cut and fill, and that was it. There was no real engineering design to it.
And that was your thesis that you guys worked on back at Newcastle.
Well, yeah, so my work was to find out what went wrong. Okay, so they could redo the specs and stuff like that for the next project. But, you know, the geotechnical factors affecting the application of pre-split blasting to rock slopes was what I wrote my thesis up on, which was portion of that.
And now, okay, so now that was how many years ago? Okay, don't have to say a number.
78.
Okay.
Started in 78. I came here in 81. It was all finished and everything.
And now how do you see some new papers? You know, you see all these new papers and your students promoting pre-splitting and this practice. And I remember I had a project where they were really worried about the vibrations on the high wall, but they were production blasting all the way up to the high wall. And they would refuse. And I was only in the industry about 1 year when I went and talked to them. I was like, why are you guys not doing buffer, trim, and pre-splits if you're so worried about this high wall? They're like, well, there's a lot of vibration that happens with this pre-split because it was, you know, det cord, and so they were only looking at the vibration. They weren't even looking at the insane amount of gas that was propagating into their high wall, just destroying it, or anything like, or even shooting in the right direction. And so I'm sitting here like scratching my head, and I called you back up after 1 year being in the industry. I said, Paul, I just told these guys they need to do this, and this, and everything. And then they said they had a meeting with Golder, I think, or you know, one of these very large consulting companies, and this guy with 50 years of experience comes in. He says, I'm wrong. And I'm like, am I wrong? And you're just like, you know, you're gonna get high vibrations. But that doesn't mean you shouldn't be doing it, because there's so many other variables that are damaging that high wall.
So whenever you got bolt blasting, you know, main blasts, okay, you're going to have a disturbed zone into that rock face. And some of the things we're doing during my PhD, a guy called Chris Windells, who worked at Dundee, and I worked with him very closely doing his PhD because we helped each other on taking measurements and stuff, was when you bash the rock, you end up with a seismic slow zone. And what happens is the joints open up, and then they've got little gaps in them. So if you want to put a sonic wave through it to measure sonic velocity, it has to go backwards and forwards, zigzag all over the place. That drops that increases the time it takes for sound to get from one point to another. So it decreases your sonic velocity of the rock mass. And you can measure these zones, and they go back fair ways, even from a 4-inch hole. We were seeing a dozen feet or so going back. So what you've got now is you've got all that rock that's shook up and it's loose in your high wall, and that's where you're coming into the problem. So that's where we use some of the perimeter control techniques to reduce that damage back, or say disturbance, and give you a better high wall. Now, one of the things is basic thing why pre-splitting causes a lot of vibrations is whenever you get a hole and you don't have a face in front of it. Okay, I've measured about 4 times the vibration from that hole. And, okay, Calconia measured 5 times the vibration, because it's constipated, right? If you're sitting there on the pot, right, and you're constipated, there's a lot of going on.
A lot of work.
Right, rather than just easy whoosh, right? And the same way in vibrations, right? I love the analogies, right?
Oh yeah, it's perfect. You got to explain it. You got to be able to get it.
Minds,
that's right.
And the more raunchy it is, probably
the better.
It's in the people's minds, but so they don't forget. And so with a pre-split, you know, over the okay, and we usually shoot about the charge diameter is usually about 1/4 over here of the hole. Over here it's a bit more, probably 1/3. But if you say 1/4 of the hole, then if you're a pre-split charge, it's got a 16th inch, about 16th of the explosive of a main blast hole, right? Okay, but it's confined, right? Because it's got all this ground in front of it. So it's going to give you 4 times at least the ground vibration. So 4 pre-split holes are going to give the same vibration as a main blast hole at the same diameter, basically. So it's okay. So I'm teaching this on a short course, and but I wasn't, you know, about pre-splitting, but not talking about vibrations. So there's one guy there, and he goes, "Oh yeah, we got to do this pre-split, and I'm really interested in how to do this pre-splitting because I've got to do it, you know, when I get back." So he's real excited about it, and he goes off, and it was at Tower Rock in Missouri, the blaster. Saw him a couple months later, and he goes, I said, how did that pre-split work? "Oh, fantastic, it's great, worked perfectly." Said, "But it was the biggest ground vibrations we've ever had." You know, and Tower Rock at that point is long way away from, occasional farmhouse, right?
Mhm.
And they got a seismograph out at the nearest farmhouse. And, it's the biggest ground vibration we ever had. I go, well, how many holes did you shoot? He goes, 120. I said, well, did you split them up? He goes, no, shot them all instantaneously. So you got 120 holes, divide by 4. Okay, it's 30. So it was like shooting a 30-hole shot with okay, all on the same blade. Right?
Earthquake Ernie.
So you got to split them up into small panels if you're close to people. It's as simple as that. But sometimes you don't get all the information across you really need to.
Right.
And you forget a little bit, and then somebody goes, "Whoa," and you go, it's great for somebody like me because it's in my head, right?
Mm-hmm.
But I think with everybody, the problem is they talk to somebody, they don't realize that it's not in that person's head, and that person is not a mind reader.
Mm-hmm.
So that person doesn't have all the information that's available to you. Okay, and so I think that's the most important thing about communication is you've got to understand that the person you're talking to doesn't have your knowledge.
That's a very good point. Well, guys, thank you again for doing another episode. Doesn't even need to be said. I hope you guys have a good, safe flight home, but I really enjoy this, and I hope we can do this again.
Great, sure. It's been a pleasure.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.